Okay, this is the introduction for lab number 11, and this is a lab on centripetal force. It has a little more calculations than usual, so I hope that you are watching it. First thing you're going to do is you're going to open up this simulation right here, and what we're going to be doing is we're going to be spinning things around in a circle, and we know that things that go around in circles are going to experience what we would call centripetal force. So I have just some preliminary questions, and we're going to have a setup where we have kind of a tube, and we're going to have a hanging mass down here, and we're going to balance it out by hanging a rubber stopper. And what we're going to get is we're going to have a couple things going on here. We're going to have a hanging mass. That hanging mass is going to provide some weight, so we're going to have mass times gravity. That's going to be balanced out by the force, and that force is going to be a centripetal force, and that's the force that's holding this stopper in. So what's making the stopper go around in a circle is going to be that force. So that's going to be my centripetal force, and this is going to be equal to my hanging weight. So let's pop open to the simulation real quick. A couple of things to note is we can mess around with the number of washer, and each washer is 10 grams. So let's go ahead and click begin. So first thing we would do is note the mass of the washers. You can click on the washers to change the number of washers. So you can click on there, and change the number of washers. You can also change the tape around. You can kind of change that radius, but you can just leave it at the default setting, which was 200. And we can also change the mass of the stopper, but we really don't need to do that. So we're going to click start, and what we are going to do is you're going to count the time that it takes to do 20 full revolutions. And what you are going to then do is you're going to change the number of washers, and then you're going to do that again. And you can kind of note that it's definitely swinging faster right over here. And you're going to do that for several sets of washers. So let's hop back to the lab, and what you can kind of see is we have the mass of the stopper and these masses. Please convert them to kilograms, and you're going to record them right down here. The hanging mass, that's the mass of the washers, and the mass of the stoppers. You're going to count the time it takes to do 20 revolutions, and you're going to record that right here. And you're going to record the radius, and please do convert the radius to meters. And you're going to increase the number of washers, and you're going to actually do this 3 times. So increase the washers, runs 1, 2, and 3. Now the next page is going to walk you through the calculations, but I'm going to kind of give you some pointers right over here. What is the hanging force? Well, the hanging force is just going to be the mass of the washers, please in kilograms, multiplied by gravity. Now the period, that's a special name for the time to make one full revolution. So if you were to take your total time and divide that by your 20 revolutions, that's going to be the period. Circumference is the circumference that thing traveled, which is going to be 2 times pi times the radius. Now the speed, what we know is we had this thing, and it was kind of going around in a circle, so going around. The speed is going to be the distance that it took divided by the time. So this is going to be the circumference divided by the period. So divided by, I'm just going to put the period. Then what we can do is we can just go ahead and square the speed, pretty straightforward. Just going to square the speed. And then we can calculate the centripetal force, and the centripetal force is going to be the mass times the speed squared divided by the radius. Then all I have you do is I have you go ahead and compare your centripetal force to your hanging force and see if they're the same. One thing I did forget to mention is this is going to be the mass of the stopper, because that's what you were kind of swinging around in the circle. So as you go down to the bottom parts of the lab here, this pretty much says everything that I highlighted up here, but that's written out, and please do show one sample calculation. So then I just have some questions thinking about centripetal force and the directions, and then just how does, let's take a look at a real life application. What makes a car go around in a circle?